Alright, Algebra 2 kids, welcome to Module 3, Unit 10. We're now up, getting about halfway through here, is Lesson 4. And we're going to look at the inverse relationships between exponential and logarithms. And you've already started seeing that, so now we're going to take a closer look. Okay, since the graph of a log for a logarithm and an exponential, so we'll call that expo to fit in there, with the same base are really reflections of each other across the diagonal of what? You should remember the equation y equals x. So a log and an expo with same bases are inverses. Can't do the E too well here, so inverses of each other. That's the key. Now, what are we going to do here? We are going to take and we're going to write y equals f of x for a formula, given formula of x. Just replace the f of x with the y. Then we're going to interchange the symbols. We're going to trade out the x's and the y's. So you'll get x equals f of y, whatever that was, that function. We're going to actually then solve for y in terms of x. And then we're going to flip it back and put in the formula of g of x, basically, for what we found in this third step. And then that's how we're going to turn out to write the inverse of one of the functions. So let's take a look at one. So, as we said, step 1, let's replace the f of x here with a y. So I'm going to get y equals 1 minus 4x. Then the next step, 2, is we're going to interchange these two in order to get the inverse. So I will get x equals 1 minus 4y. So now I'm going to try to solve for y. Many ways of doing this. I'm going to bring the x to the other side, so minus x to both sides. At the same time, I'm going to bring the y to the other side, so it's isolated and it's positive. It's mainly the reason why I'm doing it. Otherwise, I could have just moved the 1 first and then dealt with it. So these are going to cancel. You're going to be left with 4y equals, and then I'm going to have a, what, 1 let's see here, minus x. And then we're going to turn around. So what's left here now is just to divide by 4. Divide by 4. Bring my work up here. So I will get y equals 1 minus x divided by 4. So that's the end of the third step. Now all we got to do is go to the fourth step, which is to replace that with g. So thus, or you will see me do 3 dots for therefore, g of x is 1 minus x over 4. This is the inverse of f of x. That's how you create the inverse algebraically, solving. Okay, you just plug in y for the f of x, exchange the 2 letters, solve for y, and then, or solve for, yeah, we'll get there. And then put g of x back in for y at the end. Let's move on and we will look at some more examples. Alright, so next up we will go with, we'll replace again f of x, so y equals x cubed minus 3. And then we will switch the 2 around again, so x equals y cubed minus 3. So then we're going to solve for y. So, first step logically, bring the 3 to the other side, add 3. So you now get y cubed equals x plus 3. And how do you get rid of a cube? You take the cubed root. So we will take the cubed root of both sides. Suppose I could do that in a different color. Cubed root. Cubed root. So you will get y equals the cubed root of x plus 3. Therefore, last step, just replace y with g of x. G of x equals the cubed root of x plus 3. And you did it. All right, moving on to the next one. First step, when we got f of x is equal to 3 times the log of x squared, we're going to get y equals 3 times the log of x squared. Switch the variables. So x equals 3 times the log of y squared. And now we got to solve for the y. Well, one thing you can do right away is you know that this 2 right here can come out in front. So we will get x equals 3 times 2 log of y, which means x is equal to 6 log of y. And now we will divide by 6, and we will get the log of y equals x over 6. Well, we don't want the log of y, we just want y. So what do you recall? Well, I hope you remember there's a base 10 right here. So if I bring my work up here, it's pretty easy. I just say, hey, 10 raised to this power, x over 6, is equal to y. And therefore we have solved for it. So all I have to do is change this. I'm going to put thus. Therefore, g of x, instead of the y, we'll plug that in, is equal to 10 raised to the x divided by 6. And even though it's funky looking, that is our answer. That is the inverse of 3 log of x squared. Not something I don't think you would have guessed to start with. So this is not one of those things you can look at half the time and figure out what the inverse is. You get a sketch of a graph, you can learn, sketch it, what it looks like, but not the actual equation most of the time. All right, time to try some more. Feel free to pause the video and try some of these on your own too before I do them. You're starting to get used to this. Obviously, we said we replace f of x with y equals 2 to the x minus 3. Then we switch the places, so x equals 2 to the y minus 3. So now the question of what to do. Well, I'm going to pause for a second here on this. And I know if I wrote something like this, log base 2 of x equals 5, you would have no problem saying, oh yeah, Mr. O, you just got to take 2 raised to the 5th power, my bad. 2 down here, raised to the 5th power, equals x. Well, we kind of got that situation sitting right here, don't we? I just need to go and reverse it. So what I'm going to do here is this. I'm going to do log, and this is my base here because that's 2 raised to that power. So log base 2 of, forgot to write my x here before, log base 2 of x is actually equal to y minus 3. That's an equal sign. So if I want just y, all I have to do is add 3 to both sides. Add 3 to both sides. So what does y turn out to be? Well, it's log base 2 of x plus 3. And we solved for y. So therefore, or thus, g of x is equal to log base 2 of x plus 3. All right, a little different. To take it and go from this position up here backwards kind of and set up the log. So haven't done that in a while, and you got to be able to do that. All right. All right, this last one, give this one a try. Pause the video, get as far as you can, and then come back and I will have the answer sitting there for you. We can always discuss this one further in class. So in this one, did you notice that you started with f of x was equal to x plus 1 divided by x minus 1, and g of x, the inverse, turned out to be x plus 1 divided by x minus 1. Okay? And that's just reminding that this is going to be, they're going to be reflections of each other. Over the y equals x line. Therefore, inverses, which is what we created anyways, and it's a cool inverse when we get them that they're the same way on that. So it's definitely showing reflection over that. Okay, moving on a little bit more. Make sure you make a note of this if you didn't get this one right, okay, or you need help for class. Okay, the last thing we're going to look at is an exponential function right here, 2 to the x plus 1 on this graph showing there's the graph, there's y equals x going down the middle. What's the domain and range of this? Well, domain, how far to the left can it go? Well, it goes on forever to the left, so you're looking at the domain as negative infinity. How far to the right? It's going on forever to the right, so positive infinity. Or you could have told me the set of all reals. Range, on the other hand, how low does it go? Well, this is a 0 and a 2. I don't know if you can see those or not. So it's approaching halfway in between, and it should tip you off that it never gets down to the number 1. But it does go up on forever, so towards infinity. That would be my range, and that plus 1 right there is the clue over the normal exponential. Okay, then they want you to sketch the inverse. So you guys could do some points, like 0, 2, it hits there, so you know it's going to hit 2, 0. And it looks like it hits at, let's see here, at 1, or 2 going up is up at 5. So if I go over 5, I could go up 2. And you'll get this type of a picture. And it's going to come this way, but is it ever going to hit at 1 right here? And the answer is no, because you got to have the inverse. So it's not going to hug the y-axis at 0. It's going to approach 1, but not that. So that leads us to answering the questions here. What are the domain and range of this? Well, the domain of this function is what? It can't go all the way to the left. It can only go to 1. And it can go on forever to infinity. And the range on this one can go down forever, and it goes up forever. So that's the set of all reals, or you can put in negative infinity to positive infinity. Finally, the last part, take a moment. Take that function way back up here, and I want you to try to write the inverse, just like we've been doing in this lesson. So pause the video and do that. Okay, to go through it real quick. I set, instead of f of x, y equals this. I substituted, switched up the x and the y. I brought the 1 to the other side. And then I did the trick we did before. We took log base 2 of all of this equals the y. And therefore I know what y is equal to now and replaced the y with g of x. So these two are identical except g of x. And that's how you do the inverse. Last page is just a quick summary here. We'll talk in class about what to highlight. You might want to highlight a few things that you think are important, but that's how we actually come up with the inverse. So we'll see you in class.